Hey everybody, this is Larry, this is me going Q3 of the weekly contest 372, maximum XOR product. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one, not gonna lie, it's a very hard problem for me, to be frank. I got two wrong answers, oops. But, which is not why it's hard. One of the wrong answers is actually very silly and we'll go over it in a sec. But like look at this. If I show you the solution, it's not going to be pretty. But here's a couple of observations, right? So the first observation is that if you want this formula, well, you want any formula really. Like you have a multiplication, right? And you want to maximize this. The idea is that you okay, that's not true. So let me step back for a second, right? So let's think about this on a bit-to-bit. Let's think about this as a bit-to-bit breakdown, right? So this is an XOR problem. XOR means that the bits are not the bits are kind of independent. In this case, it's not fully independent, which I kind of made an error on. Not as a wrong answer, but just wasted time on, right? But basically the way that whenever I see XOR is that I break out the truth table or the Boolean table or whatever, right? So then here I have when A and B, like we want to maximize. Well, I mean the clear thing that we want to do when we maximize is that there are a couple of cases, right? There's 1 times 1. Okay, that obviously is pretty good. I mean, you could shift the digits, but it's still going to be good. You have 1 times 0, no bueno. 0 times 1, and that's no good, right? So basically the only thing that matters is 1 times 1, kind of. It's not strictly true as we kind of talk about, but we're talking about just playing around with the properties of this formula, right? First, before getting to it, right? So basically these are the 4 configurations, and this one is kind of the worst, but as you see later, it doesn't really matter that much, right? So basically here, now we have A, B, and maybe X, but we start with 1 and 0. We do all the possibilities, right? And then now what do we want this thing to be, right? Let's say we want to try to optimize for this thing. So what would X be, right? So here, well, if X is 1, then this one is 1 and this one is 1. So this is going to be 1, right? So that's good. So we want to make x1 in this case. If this is not, though, however, then this is going to be 0. It doesn't matter what x is, but it's going to be 0 because one of these is going to be 1 and the other is going to be 0 in some order, so it doesn't matter, right? It doesn't matter. It'll be 0. Same thing. Doesn't matter, and it'll be 0. And x is going to be 0, and this is a 1, right? Okay. So, okay. What does this mean, right? This means that, well, for the purpose of if both A and B have the same number or same parity, maybe at the same digit, then it's good, right? It's good because you can make both of them 1, and if you make both of them 1, that's always going to be just good, right? This is good. So then now we have to kind of maybe I'll just put it at the top instead. Here, then the question is, well, in a way, what does this mean with the x, right? So if x is 0, what does this mean, right? So let's actually break it down a little bit. So a, b, x, and then you have x XOR x, and then you have another column, b XOR x, right? So then a XOR x is going to be 1, and this is going to be 0, right? And then if 0, 1, and then x is 1, then this is 0, this is 1, right? So why does this matter? Or what does this mean? What this basically means is that you can give, that means that if they're different, you could choose whether A has the x or B has the, has the x, but also the number, right? That means that if you have like a string of numbers, say, I don't know, right? And the numbers, the digits that are different, you can choose which digit to give it to, right? Meaning that here, you like, because they're only 1 on both of them, you can make this 0 and make this 1 if you like, and they're equivalently the same, right? So that's basically the idea, but then now you have to maximize this multiplied by this. So then this is where the tricky part of the problem comes. And I think the way that I did it is with case analysis, right? Let's say for a second, when n is really big, so we don't have to worry about n. And then now you have some things, right? And then whatever. And so yeah, so then what do you do in this scenario? When n is really big and you don't have to care about n, then you have this formula that you want to optimize for, right? And basically, if you have two numbers like this, it is going to be the biggest if if is equal to, is the same as minimizing this value, right? Hopefully this makes sense. It's basically like this is a classic square type thing, right? Like if you have a rectangle of, you can think about this as a rectangle of size a XOR, I mean a XOR x, it doesn't, I'm going to convert it to f of a and of so you have a rectangle of side f of a and f of b, and of course they are going to be equal if this is going to be closest, because the most area is going to be a square, and a square means that they as close to a square as possible, so they're going to be minimized, right? So basically this problem reduces to minimizing the absolute value, or the delta between, and this is f of a minus f of b, and I'm just going to write f of, I don't know, y is equal to y XOR x, right, for the purpose of this problem, right? So yeah, that's basically it. And after that, for me anyway, I just did case analysis. There may be a easier way to do it. I think there is another way to write it, but I didn't do it this way because I don't know. I think sometimes your solutions come from a product of product how you got there, right? I think if I were to have this understanding now, I would have written it a different way so that I have fewer things to prove, to be honest. Because I think the way that I wrote it, I have to prove a few things, which is where all this stuff comes from. But yeah, so basically there are a couple of possibilities. And like I said, when you have ones in the same places or zeros in the same places, you don't have to care about them. You can just swap them to ones anyway, right? So that part is greedy. So then now what we have to think about is all these what I call floating ones, because they're floating around, and you have to figure out who to give it to, right? So I think one of I got a wrong answer on this one, which is 0, 0, 0, 0. And the idea here is just to give one of them the first one, and then the rest of them to the other one. I think so. This works because basically, this is like a most significant digit thing, right? If you give this one the most significant digit to one of them, then the rest of them should go to the other one. This doesn't always work because, for n is really big, this will work. Why? Because basically, yeah, you're trying to, equalize as much as possible. And basically, if you give ones to the other ones, then basically you're thinking about it as subtracting. So you're starting with the most significant bit, and then you're slowly subtracting from it. So it's good, that's how you minimize this part, right? But then now, what if n is really, or if it's small, or it's not small, it's 2 to the n is smaller than a or b, right? So what happens in this case is that you basically just give all the ones to the other number, right? For example, if you have some big number and you have some smaller number, and you have, let's say, Even I guess in this case it could just be here, right? In this case, because this number is smaller, to catch up, quote unquote, you want to give all the ones to that number. That's basically the idea. Yeah. So with all of that, I'm gonna go over my code, and basically, yeah, I have two ways of doing it. I give the first one to A, the rest to B, and this is my way of doing it. There are a lot of bitwise operations here. I'm not gonna go over it today, just because this video is already kind of running long. But this basically, if they're the same bit, whether they're 0 or 1, we just make sure that they're ones together. Otherwise, we give the first one to A, we move that bit from B, set it to false, and give the rest to, and then there, right? And then go to is just the same thing, except for we always give it to B. And then the way that we brute force it is that we just put it in every possible order. So we give it all to first to A, and then the rest to B, and then give the rest to B, but then swap them, right? And then mod. So yeah, the first wrong answer I had was that I kind of just got this case wrong. Not this case actually. I didn't consider the case where yeah, one of the number, this case, I didn't consider the case where one of the numbers so big, so that I didn't have this function, so I just kind of gave it all like, yeah, like in this case, I would still give the first number to here, so I would only test this case, and that's not good enough, right? Because you could still give this 1 to this 0 to make it even closer to that number. Yeah. And then the second one was that I actually had this function and go to as well. I had this return this mod, so when I maxed this, it actually maxed the post mod number, so it was wrong because of that. Very silly mistake. That was a very amateur mistake, so very beginner mistake. So yeah. So I did say that like, how would I change this if I want to, right? So I think the idea, I mean, I think this is actually a very like lean idea. Maybe I could have coded it a little bit different and a little bit better, but I think this is a reasonable idea. But the thing that I probably could have done with fewer proofs is just I would rewrite the function to be give the first k bits to A, the rest to B. And if I did that, then it'll be, then I don't have to prove as much or think about it as much, because there is this like thing, because it doesn't really, because if you have some number, it doesn't make sense that, let's say you have 5 floating ones, it doesn't make sense to kind of give a middle one to the other one and not the rest kind of thing. So that's basically the idea, and we kind of wrote it down, write this function out. Maybe you have a new go, I guess we'll do it live. Then you have something like so yeah, best is equal to 0, right? So then now for j in range of, I guess n, it doesn't really matter. No, I mean, I guess it matters a little bit. No, I mean, I think it's fine, right? So yeah, so basically, yeah, n, the first, so we want to convert this to first j bits to A, the rest to B, yeah. And then I think this has to be this, right? And then now, basically for I in range of n minus 1, and I don't even have to do this in reverse, I think I just did it for whatever reason. I guess I would just write it as best is equal to max best go A, B, J, so then it's easier to kind of thing, right? Then now we have to add in J, so that we first J bits to A, right? And then now we don't have to write it this way. I mean, it's I guess maybe it's not that much easier, but yeah, now instead of first we go if j is greater than 0, right? And that's pretty much it, right? Do I put, no, okay, give us a minute. Yeah, I think this way, even though it's obviously more work, and this now makes this n square instead of n, but I think it's just easier to, or like fewer proofs during the contest, and n of course can be only 50 or something, right? Yeah, only 50. So I think this is a safer way to write it, and I don't have to worry about like the intricacies. The jumping back, the continuous thing is easier for me to kind of visualize. But yeah, it's a very long video for kind of a not super ridiculous problem. But yeah, let me know what you think. Ask me questions in the comments. I know that sometimes people are like, I don't understand this. Listen, I get that you don't understand this, but that's not helpful for me either, right? Like, I can't answer your, like, that's a useless comment, to be frank. Like, like you're not helping me. Like, I'm not going to be like, oh, that person doesn't understand it. What can I do? Right? You have to ask a real question. If you ask a real question, I will answer it the best I can, or do it in the Discord, and I'll also answering the best I can, or other smarter people than me will answer it, right? So yeah, so that's what I have to say for this one. And you could watch me solve it live in the contest next with all the silly mistakes along the way, and you can kind of see how I debug it and so forth. Yeah. Boop. Maximum XOR product. Mod. All right, what am I doing? All right. So you can do any number. Maximum value of the XOR. Okay. Well, what does this mean? Basically, most significant bit matters first, but you can optimize every bit anyway. So basically, every bit you want either 1 or 0. Yeah, okay, that seems pretty straightforward. Maybe. It's 2 to the 4 minus 1, so okay. Yeah, okay. Right, so if 8, okay, so basically if this, so this bit will be 1 if so these two bits have, A and B bit has to be the same, right? Otherwise it doesn't even, like, it just becomes 0 for that bit. So basically if they're the same, if I guess you can just do something like this. Okay, if the bit is the same, then okay, if they're both 1s, then you want x to be 0. If they're both 0s, then you want a 1, right? But in either case, yeah, okay, fine. I don't know how to do it, so I just do if this is 1, then we want, okay, so that means that if this is a 0, then we want x to be something like this. And then now we can just return a mod current times b mod, I say mod, I meant thing. I have to remember to mod. It's a crappy problem, by the way, because I don't know that I don't know that you can do in certain languages. Oh, I got this one wrong though, so I am maybe wrong. Why am I wrong? Tell me why. Got the first two though. Am I off by 1? N is equal to 3. Current is 0. Why did I put 6? So, well, 0 is going to be 6, but why is it going to be 12? X is equal to 5. So, maybe I misunderstood this. Okay, so 6 is going to be 4 plus 2, right, over 1, right? Maybe this is harder than I thought it would be. I thought it would be just bitwise thing because of significance. Oh, I see. You still kind of want a bit, right? Maybe. Okay, so if it's 5, then it's going to be 4 or 1, right? Is the X? Basically now, basically it turns the 6 into 0, 1, 1, and then the 1 into 0, 0, 0. Wait, what? Oh, no, 1, 0, 0. And of course that's going to be 4 times 3, which is 12. Okay, so I'm really wrong on this one. Really wrong. Alright, then how do I do it? Can I do it bitwise? Or rather, well, you want them to be as equal as possible, I think. That's technically the thing. So here, so that means that you swap them kind of, right? So think about this as doing this, and then now doing this. How do you do it? So you want them to be as close as possible because this is how the product things work. This 6 and 1. Well, if they're equal, then but otherwise, basically, but so I think the answer is if n is big enough, then you just give the most significant digit to one of them, and then all the other ones to the other one. But n might not be that big, so okay. So I think we have to reconstruct this as the number of bits, right? So we cannot change the stuff that happens before. So then how do we do it? Then the things after that, I guess you just have to do, right? So basically you get one. Okay, I think I have an idea. Wow, that's kind of tough though. So it's kind of greedy-ish. Okay, how do I do it? That's a great. I mean, I know how to code it, but it's just yucky. Okay, fine. Yeah, okay, fine. Yeah. We have something like this, so the first to A, the rest to B, right? Basically, then now, what we want is, do I need current? So current would be the thing, but what if, okay, so if they're equal, then it's fine. I think I could have written this in a different way. If they're equal, then this is we make sure that they're both ones in that digit, right? If they're not equal, then first is equal to false, right? So then now if they're not equal, then if first, I guess then we give it to A, right? So A first is equal to false, else always give it to B. So this way we kind of make sure that they're as equal as possible. Kind of, not really, I don't know. And then we return 8 times B, come on. And the reason why we always do it this way, so that now we can do both, right? Max. Yeah. Oh, huh. 240. I mean, I fixed this one, but why am I so off on these other ones? Is my logic wrong? Oh, I have to do, this is an else. That's a new mistake. Alright, I was like, I don't get how that could be wrong like that. Oof. I mean, I could say I could be wrong, just not like that. 072. So basically, you want 3 and 4 again. So why am I wrong? So the 7, it went into 2 and a 5. And a 6 and a 1. So 7 and 0. Oh, it's only the last 2 digits. No, yeah, it was only the last 2 digits. Am I off by 1? I mean, no, that would give me a better solution. And since I have a worse solution, that doesn't make sense. Okay. So basically, you have 7. If they're different, then that means that we only have 1 digit, so we give it to A. So that should be a 4, right? Did I mess up? Let's take a look. I mean, the wrong answers are legit. Like, I don't feel like it was well, okay, Q1 was silly, but let's see. All right, 2 and then 5. So I pass in 0 and 7. And then basically, yeah, 0 and 7. Did I mess up on the I? No. So I give to 5, but then okay, so you have 7 and 0. Okay, you give to 8, and then the rest. But what? Why? What? Why? You give to 1 and then you give to 0. Oh, because in this case, I see. Because you're only given so you may actually give all to one number and not, because I'm trying to equalize it. But how do you equalize it? Or like in a more general way? And in this case, you want to clearly just give it all to the other number. maybe the way that I was doing is a special case, and that I don't need to do it this way. Oops. Why did I do this way? So that we have max enough, then. Oh, I see. The first significant. I see. So if. I think I could just do it again, though. I think yeah, okay, I see. I'm going to be lazy. Okay, give the rest to B. Right, so basically same thing, the same, otherwise give it to B, and then now, yeah, okay, I mean, I don't know that this is all the cases. Oh no. Is there a case where you want to give to, I mean, to keep them as equal as possible? Huh. Man, this is a struggle. I mean, I guess I'm just doing some sort of greedy, and this is not working well for this. All right, let's take a look at these two numbers. Wow, I am not doing well. How do I get them to line up? Something like that. Nope. I forgot to do this. I don't have right pads or left pads. Is it this way? Nope. I don't even know how to code anymore. I thought it is though. I think that's right. I think I just have too many digits. Is that true? Oh, it's 50. Huh. I thought it was 20 for some reason. I think that's why I got confused. Okay, there we go. So basically in this case, well, it's only 6, right? That means that only the last 1, 2, 3, 4, 5, 6 digit matters. And this is not right. Give the rest to B. Do I have any typos or anything? If they're equal, which then that's fine. We'll export them good. Otherwise, yeah. 1, 2, 3, 4, 5, 6. Right? So here we give this one to this one, and that should be good, right? No? Oh, I am dumb. I mean, I am maxing pre-mod or whatever. Wow, that's the reason though. I don't know if that's the reason, but I mean, that's a very silly mistake. But also, how do people do it without, like, I don't know. That's a... Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this prompt, the explanation, maybe everything in between. stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.